Hey, I'm back again. It's been a little while. It feels like it's been a long time. I think it may have been just a couple of weeks. Sometimes life gets in the way, you have to catch up and things happen. But I'm back and I hope to get back on a regular schedule of putting out this content that we all can learn from and I can learn along with you. And without further ado, today I want to talk about fighting obesity and new research that has been documented and put out for all of us to learn about how researchers have been fighting obesity. So a research team at the University of Colorado School of Medicine, they identified a potential target for treating obesity and metabolic diseases that could enhance the effectiveness of existing anti-obesity drugs. I don't like the idea of the drugs. That's always been a thing. I mean, I'm not saying all drugs are bad. A lot of them come from natural things like plants, but like using them for everything, because in this case, before I go further, how long do they have to be on these drugs? Because there's some things people deal with their own drugs for a long time or all their life. So I hope this is a more natural means. I don't know. It seems more natural at the same time not, because they're using anti-obesity drugs. And I know there's a few people that need it, but most of us, when fighting obesity, there's the hard way, I guess. Drugs can be the hard way, long-term detrimental effects. Anyway, to get into the details of this, the researchers at the University of Colorado School of Medicine, they did a report on the study of an enzyme known as histone deacetylase 11. I'm just going to use the abbreviation because I don't like to pronounce these long words. I want people to understand what I'm saying. So for short, it's HDAC11. So this HDAC11, which serves an important role in controlling adipose tissue function. Adipose tissue is basically fat. It's commonly known as fat. So in this study, they explained that inhibiting this HDAC11 can have a beneficial impact of causing fat cells to expand energy by inducing a protein called UCP1, or an uncoupling protein. UCP1. That's a little easier to pronounce. Uncoupling protein. It's not like trying to pronounce the word that represents HDAC11 or the word HDAC11 represents. Anyway, they say there's different types of adipose tissue and they describe it in colors. So one is called white adipose tissue, and the primary role of white adipose tissue is to store energy in the form of triglycerides. I guess that's like storing fat. And brown adipose tissue has the abundance of mitochondria, which dissipate chemical energy as heat through a process known as non-shivering thermogenesis, in part through the action of UCP1, through that uncoupling protein. So I guess that it expands energy and that protein uncouples. I guess maybe that's self-explanatory. It uncouples, and this is done through that dissipating of chemical energy that the brown adipose tissue performs, while the white adipose tissue stores energy through those triglycerides. The researchers say there's a third type of fat called beige. Okay, so now we got brown, white, and beige. This is like, there's a lot of jokes you can make from this, a whole lot of jokes. But I'm trying to stay on topic and choose my words carefully. You can come up with all the jokes in your mind. I'm sure in the comments you can post. I need to stay on topic. Anyway, so they say you take the white fat, and they say the white fat isn't normally that good. Oh boy. And you turn it into something that looks more like brown fat. They say they do this by inhibiting HDAC11, and they're stimulating the beiging of white fat. HDAC11 inhibition changes the phenotype of the fat tissue in a favorable way. Again, because the brown fat dissipates energy and the white fat stores it. So I guess the white fat is kind of what contributes to the obesity, whereas the brown fat is going to be dissipated through that thermogenesis and the uncoupling of UCP1. They say this discovery opens the possibility of fat cells that could be prompted to expand energy by targeting their distinct molecular mechanisms in adipose tissue. So it looks like they're targeting the molecular mechanisms of the white fat and making it more brown by beiging it. They said prior attempts to do this with the drugs were a failure. They used a drug called mirabegron. This one doesn't have an abbreviation. You know, these words you don't know. I guess I could Google or chat with an AI right now, but that would disrupt the flow of my video maybe. I don't know. So yeah, they focused on a receptor on the fat cells called B3AR, because I'm not going to pronounce that, or a beta-adrenergic. I did try to pronounce it, didn't I? Adrenergic receptor. So B3AR is like where they failed at trying to stimulate the fat cells with this drug, mirabegron. So they say the attempts were not successful, of course, and they say it was due to a number of receptors on the surface of the target cells being reduced. No kidding, I guess. And it also resulted in a state called adipose tissue catecholamine's resistance. Okay, so they failed with this drug to stimulate these B3AR, I guess, receptors, and that's why they chose to go this route of beiging the white fat and making it more brown. Okay, I get it. I hope you understood that. So they say through the experiments of the HDAC11 inhibition, again with that uncoupling protein and basically the browning of white fat, they were able to enhance brown adipose tissue activity. So I guess the white fat that's been beiged behaves more like the brown fat and dissipates energy, which is where they failed in the previous attempt when they were using that B3AR stimulating drug. And again, I hope I was clear. I try not to talk too fast and mumble stuff together. Please, I hope I was clear. So yeah, basically they try to brown the white fat and to dissipate the energy to imitate the brown fat. They say this discovery shows that the HDAC11 inhibition could help counter harmful effects of excess body fat, such as insulin resistance, inflammation, and fibrosis. I mean, this looks promising. I just hope that they could find a more natural way to brown the white fat or inhibit this uncoupling protein to brown the white fat. I hope, but it just looks like, I just feel like there's going to be drugs involved, of course. So the Colorado team studied the effects of inhibiting HDAC11 in mice and the human fat tissue that was surgically removed from obese patients during their bariatric surgery. Okay, interesting. Kind of like people keeping people's stem cells in a way. The same concept, they keep your tissue. So they said the same study results in separate models indicates the potential of the findings being applied in real life to treat obesity and metabolic diseases in humans, which again, this looks promising. I just don't like the idea of drugs. And there again, I think, to be honest, in my opinion, I think very, very, very few people have obesity as a genetic issue or like a more, an issue in their family. I think a lot of it is the food that's available to people, which is unfortunate right now, because I know we have to exercise, we have to eat right, and that's a responsibility on the human. But I think also the food that's available to certain people is not the best, and they do too much to it. In a lot of places, they do too much to food, and I think that's another topic. I guess people, as far as gardening, groceries, that's a whole other topic, but it's related to this, and I think it's important to just kind of touch on it. And they say that the researchers want to continue their study with this inhibition of the white fat with the ultimate goal of developing approaches to treat human diseases. I think it's important, and they say it's improved the understanding of HDAC11's functions in adipose tissue, and they want to Actually, they want to offer alternatives to existing weight loss drugs. Yeah, that's a good idea. Hopefully the alternatives, you don't involve too much of ingesting drugs, and it can basically they can find other ways to get these tissues to uncouple or brown. More browning of the white fat, and get it to uncouple more. The only thing is when they use drugs, which is a problem, the drugs lead to muscle loss. Alright? This is mentioned in the research. Drugs lead to muscle loss, and then if the patient gets off the drugs, then they put the weight back on, which is, again, I guess that goes back to diet and exercise, maybe, unless it's like one of those rare people that have obesity problems even though they diet and exercise, this is tough. And again, I'm not a researcher. This is a tough topic, especially with a lot of people dealing with this. But this looks, again, if they can do this without, I'm trying to pick a term here, invasion of drugs, it would be nice. But I could ramble on, but let me know what you think. Please like and subscribe. Thank you so much for your time, and you can feel free to make a comment and make some jokes in the comment if you like. But I appreciate it. Thanks a lot.